In this lecture, we are going to have a look at a couple of techniques which can help us prevent SQL injection attacks. So SQL injection attacks primarily work because the user input is not properly sanitized. So the user is inserting malicious characters such as escape characters, single quotes, double quotes, angle brackets, and this input is not sanitized and directly concatenated with the code. Which brings us to the second point. The fundamental problem or the root cause of the SQL injection attacks is that code and data are mixed, which is indicative of bad programming. So basically it is the code part which is creating the SQL query. So for example, it creates select static from dash where dash is dash, and now these blanks are filled by the data. So the code is generating the SQL query and the data values are plugged in. But unfortunately, as we saw, a malicious attacker can insert again code in the data values, and since this is directly concatenated with the SQL query, so that's why the final result is a malicious query which gets executed. Now there are a couple of defenses which we can use against SQL injection attacks. The first is obviously input sanitization. If we can somehow sanitize the user input and check for the presence of and remove characters, special characters such as single quotes, double quotes, angle brackets, slashes, and so on, then we can obviously mitigate against SQL injection attacks. The second defense is more sophisticated and even better, which is called prepared SQL statements or parameterized SQL statements. So the basic idea is that instead of mixing code and data, we separate the SQL query from the data and pass these two separately to the backend database. The third solution is WAFs, web application firewalls. WAFs are pretty good at stopping several different types of attacks, including malware and SQL injection attacks. We are now going to discuss each of these solutions in more detail. So starting with user input sanitization. So either we can write our own custom code. We can have our own custom user input sanitization function, which checks for the presence of special characters, such as single quotes, double quotes, slashes, angle brackets, and so on. All of these characters are almost always used by the malicious hacker to craft the malicious SQL query. Now, user input should only have strings, integers, whatever is the official purpose of the input field. It should never have these special characters. So by passing the input through our sanitization function, we can be sure that our sanitization function either removes these malicious characters or replaces them with benign characters. So that's the basic idea. But instead of writing our own custom code, because there are just so many possibilities, we can also use pre-built user input sanitization functions. Now PHP, which is perhaps the most popular programming language for developing web applications, it provides several built-in functions such as magic quotes, and there's another one, MySQL real escape string. Now both of these input sanitization functions, they scrub your user input, they check for the presence of any malicious combinations and then removes them. Now at first glance, these user input sanitization functions and this approach seems like a good idea, but in reality or practically speaking, they're not really such a great idea. And that is the exact reason why they are now deprecated and considered unsafe. The problem stems from the fact that there are just so many malicious characters, and then the hacker can also use ASCII values for these characters, which later on gets converted into the actual character. And there are always creative hackers who are coming up with new combinations, so the possibilities are endless. And that is why these solutions are considered only a stopgap solution. They are not considered a final solution. A better solution is to use prepared SQL statements, also called parameterized SQL statements. So the basic idea is that you should always separate the SQL query from the data. In fact, most of the problems stem from the fact that we are mixing code and data. So it is the code part which was generating the SQL query, but we allowed our data to be plugged in directly within that SQL statement. So when the data was concatenated and the malicious hacker was able to insert crafted messages into that data, so that resulted in a malicious query. So to avoid this problem, a good approach is to separate the SQL query or the code from the data. So in prepared SQL statements, instead of sending the raw query to the database, we don't create the final query. What we do is that we pass the structure of the query to the database, and then we inform it that we're going to send you some data values. And then those data values are passed separately as a function call to the database. So it is at the back end that the database compiles this query. Now previously, what we used to have is that we have a query select asterisk from students where name is equal to name. Now this part was the code and it was directly mixed with the data part. So whatever the input variable name had, so whatever the user inputs here, it's passed to the name variable, which is plugged directly here. So a user can, insert malicious SQL code in order to formulate the final query. So this is the mixing of code and data. But now what we do is that we pass the query separately. So first we inform the database that this is the query, this is the structure of the query that we're going to send you. So this is select asterisk from students where name is equal to question mark. And we inform the database that we're going to pass you a variable. Now once the database has this part, it is already going to construct the query. So the query part or the code part is already done. So the database is now not going to add anything to this query once it has pre-compiled it. It is only waiting for a variable. So S means we are going to pass a string and then we pass the variable student name. Now even if a malicious hacker inserts again SQL query or malicious part of a SQL query here, it will not be added to the original SQL query by the database. And in fact, it is going to consider this literally as a string, even if you put union select asterisk from students. Now the database is going to consider this as a string, not part of the SQL query. So this is how you separate the SQL query or the code from the data. It is a far more sophisticated approach and significantly better at protecting SQL injection attacks. So the final solution that we are going to discuss are web application firewalls. Now layer 7 web application firewalls can protect against a number of attacks such as SQL injection attacks, cross-site scripting attacks, malware, and several other types of attacks. The reason that layer 7 web application firewalls work so efficiently and effectively is that they do not perform basic scanning. So for example, traditional firewalls, they just looked at the headers, for example, transport header, application layer header, IP headers, port information, IP addresses, and other things. But layer 7 web application firewall can perform deep packet inspection. It can actually check the contents of the packets, not just the headers. And then based on the contents of the packets, it can develop patterns. It can even identify which application is running. For example, is it Skype traffic? Is it video traffic? Is it simple browsing traffic? So it is very sophisticated. It can perform deep packet inspection, and then we can leverage techniques such as machine learning and other mechanisms in order to detect any kind of malicious pattern. Another thing that they do is that they have baselined the normal behavior of the system and the network, and if they see any deviation or abnormality compared to that baseline, this also triggers an alert. So web application firewalls are a brilliant idea and should almost always be used because they don't just only protect against vulnerabilities, they also protect against malware and several other types of attacks. Now web application firewalls come in two flavors. You can have an on-premise WAF or cloud-based. For on-premise WAF, you can use one, for example, by Cisco, and there are others as well, such as Juniper. For cloud-based WAF, Cloudflare, and there are some other third-party solutions in which you don't actually host your firewall within your premises, but your traffic is passed or scrubbed through these cloud-based WAFs. So WAFs are another technique, an efficient technique to protect against SQL injection attacks because they can detect the pattern of the traffic. They can detect whether somebody is trying to inject SQL injection code because they can inspect the contents of packets as well. So that includes our lecture on mitigating SQL injection attacks. So once again, I'd like to reiterate that SQL injection attacks are very pertinent, very true, and very applicable even today. And that's why it's always a good idea to use multiple techniques to mitigate them: user input sanitization, prepared SQL statements, and WAFs.